So we are now on the flip side of the contest, and it is about almost 2 a.m. local time. I'm going to try and film as much as I can. I'll probably only get out about 15, the first 15 of the AMC 10, hopefully, fingers crossed, before my energy's just gone. I will also try to get out probably the first 10 or so of the AMC 12. It'll get you started. I did solve up until around 15 on the AMC 12, and I solved till around 19 on the AMC 10 so far. But I'm not going to get all of that filmed in the small amount of time that I have. Try to get this released at 5 a.m. But here we go. Let's get started. As far as my thoughts on what I think cutoffs and all that will be in difficulty, I will make a separate video talking about that. For now, let's just get started. Andy and Betsy both live in Mathville. I'll just say briefly, I did think the A test was quite challenging, meaning I think the cutoff's going to be like the 2024 10A from last year, probably around that level. I don't think it gets any higher than 96. There was just a lot of weird thought processes and time-consuming problems. I don't know. That's kind of my gut feeling, though, and that's what I'm going to go with. As far as the 12 goes, you can bet sub 90, maybe low 80s, maybe 87, I don't know, sub 90 somewhere. Andy and Betsy both live in Mathville. Andy leaves Mathville on his bicycle. Same problem for both of them, by the way. Leaves Mathville on his bicycle at 1:30, traveling due north at a steady 8 miles per hour. So here's Mathville. He's going to go north. Andy is traveling at 8 miles per hour. Betsy leaves on her bicycle, same point, 2:30, so hour later. So this is an hour later. She's going to be going due east. So this is at 1:30 and 2:30, and traveling due east at a steady 12 miles per hour. So she's going 12 miles per hour. At what time will they be exactly the same distance from their common starting point? So, I just look at it and go, what's the least common multiple? And I hope that's it. And then it is, actually. You get 24 here after 2 hours, and this one would be 24 after 3 hours, which is good because in 3 hours from his time, it'll be 4:30, and in 2 hours from there, it'll be 4:30. So those kinds of things, you don't have to always do an equation. You can just use logical guessing, and you anticipate they're going to be a multiple of each other, or a least common multiple of the two numbers is probably going to play a role. And if it didn't work, you could reason from that point as well to keep going. So it's going to be 4:30. Let's get on to the next problem. Continuing on with this rapid fire set for both the 10A and 12A, this was problem 2. A box contains 10 pounds of a nut mix that is 50% peanuts, 20% cashews, 30% almonds. So let's just go with that. 50% of 10 is 5 for peanuts. 20% cashews is going to be 2 for cashews. And the almonds are going to be 30%. Because it's 10, you're just breaking the 10 pounds into 50, 20, 30. Easy conversion. A second nut mix containing 20% peanuts, 40% cashews, and 40% almonds is added to the box, resulting in a new nut mix that is 40% peanuts. So if I took the peanuts that are here and I add them and I get 40%, 20% peanuts in the new one is 0.2x, where x is going to be the total over here that we don't know what it is, like we know the 10. So this is your total amount of the peanuts on top, and it's going to be out of 10 plus x. That is your total amount of pounds of nut mix in both the first set and the second set. You're going to set this equal to 40% because we had 20% of this x, which is 0.2x. That goes with this plus that over the total now needs to equal 40%, which is 2/5. So all we're going to do from here is cross multiply quickly, and it's really nice. You get 25 plus x, and on the other side you get 20 plus 2x. Move x over here and 20 over there to get x is equal to 5. Once you have that x is 5, what are we doing? How many pounds of cashews are now in the box? Well, 40% of the x, or 0.4x, is cashews. So if we have 5 pounds, 20% of 5 is 1, so 40% of 5 must be 2, and so you're going to have 2 pounds of cashews here, and you already had 2 pounds of cashews there, so the total will end up being 4. These are cashews, so it's 2 plus 0.4 times 5. You can also just multiply that, and you'll get 2 as well, and add it to this 2 to get your total answer, which is B, 4. Let's get to question 3. All right, so continuing on with the rapid fire for both 10A and 12A. It was the 10A problem 4, it was the 12A problem 3. A team of students is going to compete against a team of teachers. This is the first question on both tests. I thought it took a significant amount of time. If you spent 3 minutes on this, I don't think that's a problem. If you spent 5 minutes, it might not be bad. There's a lot of things to classify as a variable or an unknown, and there's a lot of equations to make, and it takes a little while to kind of figure out what the best approach is. I wouldn't even be surprised if some of you skipped. I don't think it's a terrible skip to go leave and come back to later on just because of how long the wording is. Okay, but going to compete against a team of teachers in a trivia contest, the total number of students and teachers is 15. I'm going to write x plus t. I don't like s for students, and t sounds good for teachers, is 15. Ash, a cousin of one of the students, wants to join the contest. If Ash plays with the students, the average age on that team will increase from 12 to 14. So we are going to use a small notebook concept here, even though I didn't mention this one in the most recent class in all the classes, but the formula that I like for averages is the sum subscript n over n equals the average subscript n. So the sum of n things divided by the number of things is the average of those n things. That's how you want to think of it. So if we do that for the students here, this is the preferred averages formula. You get a lot of use out of this. I probably use it at least 6 times on the contest. So you're going to go sum of the students over x is currently 12, but if Ash joins them, then it's going to be the sum of x students plus Ash, which will be A, divided by x plus 1, the same x that we had before, and this is going to make it 14. Of course, after you write these, you should probably immediately multiply across. So then over here, I have the sum subscript x plus A is 14x plus 14. Now we go to the teachers. If he plays with the teachers, the age decreases from 55 to 52. I'm going to go ahead and take this t and subtract x. And so now we're going to say that the sum of the t over t is 55. So we can just go straight to 55t. You kind of get warmed up on this and you don't write the original equation anymore. You just go straight to the other one. We also know that the sum of the teachers plus Ash is going to equal 15 minus x is the number of teachers. Interesting. So we could probably replace this t if we want to later with 55 times 15 minus x as well. So over here, we would be dividing by what? By t plus 1, and it would equal 52. But instead of putting t plus 1, we're going to put 15 minus x plus 1. Okay, so now what are we going to do? How old is Ash? All of these unknowns, the t, the x, and the A is the one that we're looking for. So what I would probably do is simply drop this 12x into the sum of x here, and I'm going to go ahead and subtract it over to here to get that a is equal to 2x plus 14. Over here at the same time, I'm probably going to do the same thing. I'm going to take this and put it over here. So I've got 55 times, I'm going to distribute as I move, minus 55x plus a, and a is going to equal 2x plus 14. This is going to equal 52 times 15 minus 52x plus 52. So now what I'm going to do is I'm going to take this. This is another trick on the contest too. Don't calculate unless you have to. Do not make a giant big number here. Look at how much better it is to keep. I've got 52 of these 15s. I've got 55 of these 15s. If I subtract this over to here, I will have 3 of those 15s. So I have 3 times 15. If I add 55x to the other side, this 52x will give me 3x. So I've got 3 times 15 plus 2x plus 14 equals 3x plus 52. So from that point, I am probably going to move the 2x over to here to get x equals. I've got 45 and 14 is 59. I'm going to have x equals 7. 45, just to double check, 45 and 14, 59 minus 52 is 7. Cool, we're going to take that 7 and put it right here in for a. 2 times 7 plus 14 is going to be 28, and that will be kind of clever. They put it as a. Ash, which was a. It's yeah, kind of nice there, right? So there's a lot of little things you have to do in here. It might take you a while to set this up. Just because I wrote it this quick on the boards, I'm just making a video. When I solved this test myself to see what it felt like as the student, I think I took probably about 3 minutes on this problem just to kind of get my bearings for what I wanted to create for the variables and the substitution and kind of figure out how that was all going to roll out. Let's go ahead and get to the next problem. Again, if you like logical reasoning problems, which is all this one is, you can pick up some speed on this problem as well. A lot of you might have gotten paralyzed and not sure how to begin. How you begin is just with assumptions. You just make an assumption and you test it out. Let's see what that looks like. Agnes writes, this is problem 8 for the 10A, 12A problem 4. Agnes writes the following 4 statements on a blank piece of paper. At least one of these statements is true. At least 2 of these statements are true. At least 2 of these statements are false. Or at least one of these statements is false. So there's 4 statements. Each statement is either true or false. How many false statements did Agnes write on the paper? I don't know. Let's assume that there's I don't know, only one false statement. If there's only one false statement, okay, that would be this one right here would be true then. Because we said there's at least one of these statements is false, so this would be true. We're saying there's exactly one false, but at least 2 of these are false is now false. That must be false. At least one of these statements is true. Well, we do have a true one down here, so that's a true statement. And now there's 2 true statements, so that makes it true. Wait, I think we just solved it. The answer is going to be B1, B1. And you can kind of go, well, wait, that was kind of too easy. Let's make another assumption because I don't trust myself. Great, you should probably not trust yourself. What if your reasoning was terrible here and you just tricked yourself or something? So we're going to cross this out. We're going to block it in over here rather. We're going to say that there's 2 false statements now. So if there's 2 false statements, then both of these statements are true. But that means this one's true, right? This would be true because there's 2 false. Then this one's true. And then at least one of these statements, they're all true then, which means none of them ended up being false. It doesn't quite fit. Something's wrong with that, right? So when you said that there's exactly 2 false statements, both of these statements become true. If I say there's 3 false statements now, let's do that. 3 false statements, then there must be 1 true. So this would be true, but this would be false. But this becomes true because there's 3 false statements. So at least 2 of these are false. Yes, because 3 of them are false. But wait a minute, how can this be true and this one also be true if there's 3 false? It doesn't fit. Does that make sense? So that's how you can go, oh, okay, I get it. That's it. Now you might feel confident. It really is just B1, and you just figure it out by guess and checking like this and thinking about the implications of each one. One more time, if there's 1 false statement, there's only 1, we have to find it, we don't know where it is, this statement is true because at least 1 is false. When I go here, it says at least 2 are false, but that's not true. Only 1 is false, so this becomes a false statement, therefore fulfilling it being the 1 false statement. Then that means at the next one up here, at least 1 is true. Yes, that one was already true, so this becomes true, and this becomes true because 2 of them are true. And that's how that works. Let's get to the next one. Continuing with 10A problem 13, the last problem of 12A's rapid fire set for 1 through 5. In the figure below, the outside square, this one, contains infinitely many squares, each of them with the same center and sides parallel to the outside square. The ratio of the side length of a square to the side length of the next inner square is k, where k is a number between 0 and 1. What that would mean, think about what that means. It means that we're going inside, that this side length here is k times whatever this is. And this one is k squared times whatever this is. And this one is k cubed, and so on. Okay, the spaces between squares are alternately shaded as shown in the figure, which is not necessarily drawn to scale. I didn't put any more than this because it's too much space in there, but you had the picture on there, you kind of remember what it was. The area of the shaded portion of the figure is 64% of the area of the original square. What is k? I thought, well, I don't know how to start, but 64% plays really well with 100. So maybe I'll just call this length 10 and 10. But we don't know they're 10. In fact, it doesn't matter what you put, it's still going to work out. So I'm going to put 10 because it gave me comfort. Maybe it'll be easier to do if I do that. So what do we do next? Well, this outer ring, if you will, of the square ring is going to be 10 squared minus this part right here is going to be 10k. So it's going to be 10 squared minus 10k quantity squared, right? Because I'm multiplying 10 by the scale factor k, which makes it smaller. And I'm going to take that and I'm going to add the next ring. This nut right here, this side right here is going to be 10k squared. So now we're going to do 10k squared squared, because it's an entire square's area, minus this one right here, the inner square that's white, is going to be 10k cubed. And you have to square that. So it's minus 10k cubed, and I'm squaring that. And so my hope was that we can find a pattern in what's happening, probably an infinite geometric sequence, because infinitely many, that's what you would expect. And this will go dot, 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 and it's going to equal, this is the total area of the shaded region, it's going to equal 64 over 100, 64% of the whole thing. And it wants us to find k. So let's go ahead and clean this up a little bit. It's going to be 100 minus 100k squared, and then plus 10 squared is 100, k to the 4th, and then minus 100 k to the 6th. And you can see now that we're going to factor out 100. And we're going to have 1 minus k squared plus k to the 4th minus k to the 6th plus, and there you can see your infinite series as we anticipated. So what I want to do now is go ahead and I guess you would probably simplify this. I needed some space, so I'm going to have to erase this right here, unfortunately. You'll have to go back in the video to get that because there's just not enough space to solve on my whiteboard with what we have written. So I'm going to have then 100. Well, actually, this was only equal to 64, not 64 over 100, because our whole thing was 100, so the shaded region's area was only 64, not 64 over 100. In fact, this 100 will divide over there to give us that. So we're going to have 100 times, what is the sum of an infinite geo? It's a sub 1 over 1 minus r. So our a sub 1 is 1. And our r, what are we multiplying by? 1 times negative k squared. You can always check by taking this term and dividing by that, taking this term and dividing by that. If you get the same thing consistently, it's geometric, and that same thing is negative k squared when you simplify. So that's going to be what we put here, but make sure you put negative k squared, like that. And this is going to equal 64. I'm going to go ahead and divide by, 4 right now. Well, I'll put this underneath, and I'm going to write 25, and here I'm going to write 16. So I divided this by 4, and I divided that by 4. Now I'm going to have 1 over 1 plus k squared. The negative is not being squared. It's outside. It does not get squared by that. Is equal to 16 over 25. We cross multiply 25 equals 16 plus 16k squared. We subtract, we get 9. We divide by 16, and k will equal 3 over 4, which is answer choice D. Let's get down to the next problem.